2. The rules of sentential logic. We begin by stating the first principle of predicate logic derivations. Every rule of system SL sentential logic is also a rule of system PL predicate logic. The converse is not true. As we shall see in later sections, there are several rules peculiar to predicate logic, that is, rules that do not arise in sentential logic. Since predicate logic adopts all the derivation rules of sentential logic, it is a good idea to review the salient features of sentential logic derivations. First of all, the derivation rules divide into two categories. On the one hand, there are inference rules, which are upward-oriented. On the other hand, there are show rules, which are downward-oriented. There are numerous inference rules, but they divide into four basic categories. I1 introduction rules in rules and I2 simple elimination rules out rules and I3 negation elimination rules tilde out rules and I4 double negation, repetition. In addition, there are four show rules. S1 direct derivation, S2 conditional derivation, S3 indirect derivation, first form, S4 indirect derivation, second form. As noted at the beginning of the current section, every rule of sentential logic is still operative in predicate logic. However, when applied to predicate logic, the rules of sentential logic look somewhat different, but only because the syntax of predicate logic is different. In particular, instead of formulas that involve only sentential letters and connectives, we are now faced with formulas that involve predicates and quantifiers. Accordingly, when we apply the sentential logic rules to the new formulas, they look somewhat different. For example, the following are all instances of the Arrow-Ab rule, applied to predicate logic formulas. 1 fa ga fa. Ga 2 xfx xgx xfx. Xgx 3 fa ga ga. Fa 4 xfx gx xfx xfx. Xfx gx. Thus, in moving from sentential logic to predicate logic, one must first become accustomed to applying the old inference rules to new formulas, as in examples 1-4. The same thing applies to the show rules of sentential logic, and their associated derivation strategies, which remain operative in predicate logic. Just as before, to show a conditional formula, one uses conditional derivation. Similarly, to show a negation, or disjunction, or atomic formula, one uses indirect derivation. The only difference is that one must learn to apply these strategies to predicate logic formulas. For example, consider the following show lines. 1 fa ga 2 xfx xgx 3 fa 4 xfx and gx 5 rab 6 xfx xgx. Every one of these is a formula for which we already have a ready-made derivation strategy. In each case, either the formula is atomic, or its main connective is a sentential logic connective. The formulas in 1 and 2 are conditionals, so we use conditional derivation, as follows. 1 fa ga cd fa as ga. 2 xfx xgx cd xfx as xgx. The formulas in 3 and 4 are negations, so we use indirect derivation of the first form, as follows. 3 fa id fa as. 4 xfx and gx id xfx and gx as. The formula in 5 is atomic, so we use indirect derivation, supposing that a direct derivation doesn't look promising. 5 rab id rab as. Finally, the formula in 6 is a disjunction, so we use indirect derivation, along with tilde wedge out, as follows. 6 xfx xgx id xfx xgx as. xfxo xgxo. In conclusion, since predicate logic subsumes sentential logic, all the derivation techniques we have developed for the latter can be transferred to predicate logic. On the other hand, given the additional logical apparatus of predicate logic, in the form of quantifiers, we need additional derivation techniques to deal successfully with predicate logic arguments.